Hello and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we are starting into chapter 6 and we are going to look at the use of recursion for repetition. So to help illustrate this, really I want to focus on the second part of this first, repetition. We want to make it so that our programs can do something many times. Now, this is actually something that really plays to the strength of computers. One of the real big advantages of computers over humans is that you can get a computer to do a task repeatedly for you many times, and it doesn't get tired or bored, and its error rate is extremely low, whereas humans don't have that. If you ask a human to do the same repetitive task over and over again, at the very least, they will have a very low job satisfaction. More than likely, though, they will start messing up after a while. So let's talk about how we can add this into our programs, and we're going to start with what we know right now. So I'm creating a file called countdown, and so given the name, you can kind of guess what I'm going to ask us to do. I want us to count down from 10. Okay. If I asked you to do that right now, so I want you to write a program that prints the numbers from 10 to 0 counting down. Well, how you would write that, actually, right now is just to print line and then copy 876543210 and then come in here and change the numbers. And this would do what I asked for. It would print the numbers from 10 down to 0 in that order. However, hopefully you see this as a very unsatisfying solution. Why is it unsatisfying? Well, a number of reasons. One, what if I said instead of 10, actually let's do a countdown from 100? Well, that would start to get tedious. And you notice that the tedium is not put on the computer. The tedium is put on the human, because the human has to do the cut and paste and has to edit things, and really we're not very good at that. Okay, so this isn't the way that we want to do things. It's even worse than that, though. Imagine if I wanted to be able to put in here what number do you want to count down from? Okay. And now I have the user input a number. Well, how would we do that? Because given this approach, we are hard coding exactly what we're counting from and to. Okay, there's no ability for this to vary. If the user types in 100, well, we'd have to have 100 lines, and if they typed in 5, we'd only need 5 lines. Okay, how would we get it to do that? And the answer is, given what we've talked about, we haven't seen in some ways how to do it. This approach is insufficient. Okay, even if you would be willing to do the cut and paste and edit things for counting down from 1,000, which hopefully you wouldn't, but even if you were, it still doesn't allow you to do it a user input variable number of times. Okay, that's still a limitation that we have, and so I want to get away from that. What if I made this an even simpler problem? So I'm going to say, I don't want you to count down from 10. I just want you to print the number 10 times. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Reasonably easy for the human. If I asked you to do it 1,000 times, you could, copy these 10 and paste them to get 100, and then you could copy the 100 and paste them to get 1,000. This is not too horribly painful because you don't have to edit these things, but it still lacks the flexibility. It still can't do this. And, at a certain point, if I asked you to do it 1,000,000 times, you would probably consider giving up. So how can we get around that? And so let's start with this easier problem of, I just want to print a given value a bunch of times. And let's just say right now I want to do it a whole lot of times. So if I were to write a function that prints a value, so I'll say n is the value that I want to print. And I'm making this a procedure. It's not supposed to return anything. It's just supposed to print. And so this does a print line of n. This really isn't all that useful as a function right here. And if I were to use it at this point, I could call print value, 10 times or 20 times or 100 times down here. But after I'm done printing the value, in some ways, what do I want to do? Well, I want to print the value again. So having functions, if instead of just being a single print, this had been something longer, you might have thought it was useful to write this function and then copy and paste calling the function multiple times to make it happen. And that is a possible advantage of the functions. But if the number of times starts getting large, once again we hit this thing where the copy and paste is a fundamentally horrible way to repeat the behavior. So what I've done here looks a little bit odd. Let me put in a call to here. So when this runs as a script, it hits here and it basically processes, says, okay, we have a function, and it comes down to here and it prints a prompt and it reads a number, and then it calls print value, which causes the execution to jump back up to here, and whatever number we input is put there. And then it prints that value. And what happens next? Well, it calls itself. So it jumps back up to here and it prints that value. And then it calls itself and it jumps back up to there and it prints the value. And you can see what's happening. This is actually just going to keep going and going and going. It's going to print this lots and lots of times. Okay. And there you go. I'm going to hit Control C. Because this is set up, it will never stop. It keeps calling itself over and over and over again. Now, in some ways, we get the benefit of the computer. The computer is perfectly happy to say, oh, I'll just keep doing this forever, until you hit Control C or tell me to stop. Humans wouldn't do that so well. But clearly, this having a function call itself gives us our goal of doing something many times. And this is what is called recursion. Okay? So a recursive function is a function that calls itself, or that is, in mathematical terms, is defined in terms of itself. Now, this one has a fundamental problem with it, and that fundamental problem is the fact that it keeps going forever and ever. So it's called infinite recursion. And most of the time, you don't want your recursion to go infinitely. You want it to stop at a certain point. Okay? And so I am going to write another function, going back to the name of the file that we had here, that looks at how we could do that. And this one, instead of printing the same value many, many times, is going to do our countdown. And part of the reason for that is that the countdown here is going to be kind of natural. So I'm counting down from n. And hopefully it's obvious that part of the counting down from n is to print n. And after I've printed n, so if I'm counting down from 10, I print 10. What do I do next? Well, now, the answer that a lot of students want to give at first is, well, then you print 9, and then you print 8, and then you print 7. And that is a correct answer. But I want you to look at this problem in a slightly different way. If you're going to count down from 10, you say 10, and then instead of looking at just the next step, look at everything you have left to do. What do you have left to do? Well, you are supposed to count down from 9. Which means that you're going to do the exact same action, but you're going to do it from a one smaller number. Okay? And instead of calling print value here, we can do this. I'll put in 10. Oh boy. You can see what's happening there. It is counting down, but it's gone negative. There was nothing it told to stop at 0. When you write recursive functions, so in order to be recursive, it has to have at least one situation where it calls itself. In order to make it stop, though, you also need something called a base case. Okay? You need some situation where it doesn't call itself, because if it always calls itself, then you get this infinite recursion, and it just goes forever and ever. In general, when you're writing recursive functions, you need to have a base case. When was I supposed to stop counting? Well, based on what I typed in earlier, I wanted to count only if n is greater than or equal to 0, because I was counting down from 10 to 0. Okay. So this conditional in here provides a base case for me. If n goes negative, I just jump to here and I'm done. I don't do the recursive call. And so that prevents this from being infinite recursion. But the recursion can still happen many times. So if I run this and I type in 10 now, boom, it counts 10 to 0. If I run it and I type in 100, it counts down from 100. And I can do this for larger numbers as well. 10,000. There you go. Okay. That was much easier than me having to type in print line 10,000 times and edit the numbers on it. So this recursion gave us the ability to repeat something over and over and over again. And we're just using the ability that a function can be called multiple times. And instead of calling it multiple times from down in the body of the script, we're calling it multiple times by having it call itself. And that's the fundamental difference in the logic. So that's your first introduction to recursion, just building up the idea of doing repetition by having a function call itself multiple times. In the next video, we'll look at some activities or some different functions, maybe some mathematical functions and other examples of things that we can do as opposed to just counting down by writing recursive functions.